Assalamu alaikum. So today we will start some problems of partial differential equation ODE, homogeneous, non-homogeneous, first order, second order, and so on. Okay, we will check homogeneity, we will check exact solutions, we will check homogeneous solution, different types of solution we will check in this problems. Okay, so let's start first problem 7.2.1. What's the statement? From Kirchhoff's law, the current in an RC circuit obey R di by dt plus 1 by ci equals to 0. So this is our first order. You see, this is first order differential equation because the highest power is 1. Find it. You have to find the current. Okay. The second thing for capacitance. 10000 microfarad charges to 100 watt and discharging through resistance 1 mega ohm. Find current, circuit current I from time t is equals to 0 and time t is equals to 100. So you have a given of capacitance which is 10,000 microfarad, and voltage is also given which is 100 volts, and time is also given you time at t is equals to 0 and time at t is equals to 100. You have to find the current. Okay, when the resistance is 1 mega ohm. So first of all, how you will start your problem? You first have to separate variables by separation of variables. So take this r di by dt plus 1 by ci. First you have to move this I to this side. See, the r di by dt, first move this to other side, 1 by c. Now move this I to the r once, so and go r to the other side. You will get minus 1 by rc dt. Move this t to the other side and di, and move this I to di side, so di by I minus 1 by rc dt. Now you have to integrate. After integrating, here is your function, and upside there is a derivative of that function. So once you have a function and upside there is a derivative, you will take ln of I. So because the function is I, so ln of I. Minus rc is the constant with respect to t, so minus rc goes backside, and you have to take the derivative of dt which is equals to t, so minus t by rc. And along with that integration, a constant must occur, so I take the constant ln of alpha. Understood? Now to remove this log, natural log, you have to take exponential, okay. So after taking exponential log cancels each other, you will only get I, and other side when you take exponential, and all the other things move up power of the exponential, so e power minus t by rc, and also e power ln of alpha. Okay, so now you conditions are given here, like you have to find current at t is equals to 0 and t is equals to 100. So first of all, find that t is equals to 0. So you have to just put the value of t inside your final results. So this is your final result of I of t. You just have to put the value of t which is 0. So e power minus 0 by rc means e power 0, and e power 0 which is equals to 1. So 1 multiplied by alpha, you will get only alpha. So I of 0 means I at time equals to 0 equals to alpha. Okay, so here in main equation there is alpha, so you have to replace this alpha by I naught, because alpha is equals to I naught. So you just have to replace. Okay, so after replacing, you will get your final function I t equals to I naught e power minus t by rc. Understood? The next thing, also there are many things which are given, like capacitance, like resistance, like voltage. Okay, so by Ohm's law, V is equals to IR. If you want to find current, you have to find current. So if you want to find current, I becomes equals to V by R. You have to put the value of V, which is 100 volts, and you have to put the value of resistance, which is 1 mega ohms, means 10 raised to power 1 multiplied 10 raised to power 6. Okay, 1 mega means 10 raised to power 6. So after calculating, you will get your final results equals to 100 microamperes. This is the value of I naught, and here is your main equation. So you have to put I naught by 100 micro ohms. See, I just replace I naught by 100 micro ohms, e power minus t rc as remains. Now the other thing is, you have to find the value of current at time equals to 100 seconds. So put the value of t which is 100 seconds. After substituting, you will get your final results which is equals to I 100 means current at 100 seconds time, which is nearly equals to 999.9 micro ampere. So this is your first problem. Now move towards the next problem. The statement is the decay of population by catastrophic two-body collisions is described by dn by dt equals to minus kn squared. This is a first order non-linear differential equation. Derive the solution nt equals to n naught 1 plus t by tau naught power minus 1, where tau naught equals to k n naught power minus 1. This implies an infinite potential as t is equals to minus tau naught. So this is your first order. You see, first order, the power of derivative is 1. So this is first order differential equation. Also it is non-linear differential equation. Okay, so you have to show your non-linear first order differential equation. You have to derive this nt equals to n naught 1 plus t by tau naught power minus 1. Understood? So how to solve ODE? First of all, you just have to take you have to solve means separation of variables, means you have to separate variables. So this is your main function dn by dt equals to minus k n naught n square. By separation of variable, you have to move this n to dn side and move this t to k side. So after cancellation, you will get your final results, which is equals to this d1 by n equals to minus k dt. So to remove this derivative, you have to integrate on both sides. After integrating, this d cancels with this integration, you will get 1 by n, and minus is constant, k is constant, this move back side, and the derivative of d and the integration of dt is t. So minus kt, and c is the constant of integration. After this, you have to what you have to use the conditions which is given. The first condition that is given is at t is equals to 0, you have to use t is equals to 0. So this is your main function. Now you have to put at t is equals to 0. After putting t is equals to 0, k multiplies by 0 equals to 0, and 1 by n naught becomes equals to c. So here 1 by n naught becomes equals to c. So this is, as again you have to write the main equation, which is 1 by n equals to minus kt plus 1 by n naught. Okay, here the c is replaced by 1 by n naught because the answer of c is 1 by n naught. So c is just replaced by 1 by n naught because we have to find nt. So that's why I have to move this nt upside. So after moving upside, you have to take reciprocal of this. After taking reciprocal of this, you will get this relation. You have to calculate this by your own. Okay, so next, after substituting, you will get your final results, which is equals to n naught kt plus 1 power minus 1. One more thing is given in your question, that tau naught equals to k n naught power minus 1. Tau naught equals to k n naught power minus 1, or you can say 1 by k n naught. So k n naught become equals to 1 by tau naught after taking reciprocal of this. Okay, so here k n naught is there, so you have to replace it by 1 by tau naught. So t by tau naught it becomes. So n equals to n naught t by tau naught plus 1 power minus 1. So this is your final relation which you have to prove. Understood? Okay, so now move towards the next problem, 7.2.5. Okay, what it says: a boat coasting through the water experience a resistive force population proportional to mu power n, mu being the boat instantaneous velocity. Newton's second law leads to the mdv by dt equals to minus k mu power n, with velocity at time equals to 0 becomes equals to v naught, and x at t is equals to 0 also equals to 0. Integrate, you have to integrate and find the value of mu as a function of time and mu as a function of distance. These two things you have to find. Again, you have to write first of all your expression, which is mdv by dt equals to minus k mu n. This is also first order differential equation because the power of derivative is 1. Okay, so after separation of variable, you have to move this mu n to dv mu side and m and dt to other constant side. Okay, so after moving, you have to integrate. M is constant. After you have to take the integration of mu power minus 1 with respect to d mu and 1 with respect to t. Minus k is constant with respect to dt. Okay, after calculating integration v power, what is the integration of v power minus n? V power minus n plus 1 divided by minus n plus 1. So you see here. And what is the derivative of dt? It's t, so minus k t. And what is a? A is the constant of integration. So after resolving your complete procedure, you will get this relation. Okay, then again the condition is given, you have to put the value t is equals to 0 and your expression becomes equals to v naught. So after putting the value at t is equals to t naught, means you have to put here k multiplies by 0 equals to 0. So a becomes equals to this after putting t is equals to 0. So a becomes equals to this. So see, here becomes equals to this. Also where there is v, it is replaced by v naught. So see, v is replaced by v naught. So this is your final relation. Minus n minus 1 multiplies by constant, it's a constant, you can say c, and m divided by n constant divided by this m also becomes equals to constant. So actual is constant equals to v naught power minus n plus 1. Okay, so you have to replace where is your main equation. Here is your main equation. Here the constant is replaced by v naught power 1 minus n. Okay, so see, v power 1 minus n equals to minus k by m t 1 minus n plus v 1 minus n. C is replaced by this. Okay, m and this m divides this side and this n minus 1 multiplies to this both. After substituting you will get this relation. Okay, so to remove this 1 minus n power, you have to take the root of 1 minus n. So it cancels, 1 minus n cancels with 1 minus n root. So you will get this n power 1 divided by 1 minus n. Okay. Okay, so what's next? As you know, your first relation is this. This is our final relation for Vt. But here is again a new procedure to solve the value of Vt, which is that as d mu by v and v power n equals to minus k by m dt, integrate both sides. This is the second procedure. Similarly, after separation of variable, you have to take integration, and integration you will see what I am taking here. I am taking n equals to 1. Here I am taking n equals to 1. Okay, so yes, n equals to 1. So when n equals to 1, here you can see when n becomes equals to 1, so it becomes d mu by v. So d mu by v minus k by m dt. So if you take n equals to 1, so this is the procedure. This becomes equals to ln of v. Okay, ln of v minus k divided by m is constant. It is similar here, and integration of dt becomes equals to t and the constant of integration. Okay, so to remove this you have to take the exponential. Exponential cancels with ln, it becomes only v here, and this minus k by m goes up to the power of exponential, and this constant after putting the value at t is equals to 0, it becomes equals to v naught, similar as we done before. So this is your simple problem. So the next problem is 7.2.7. What its statement? The differential equation pxy dx plus qxy dy equals to 0 is exact. Show that its solution is in the form of this. So using the relation of exact, you will show this relation. So this is simple problem. So as the concept of exact equation pxy dx equals to qxy dy equals to 0, which is given, we know if our problem is exact, then we have to take partial p by partial y, which is equals to partial q by partial f. If this is same, we can say our question is exact. So to check it is exact or not, we have to take the integration of p of xy with respect to y. Okay, so compute partial p divided by partial y. Now we have to take the potential, which is also equals to this. So psi of x also equals to this. For first equation, partial psi by partial equals to p of xy, integrate with respect to x. So psi of xy becomes equals to, you have to take the integration of p of xy plus c. Similarly, for partial of xy, you have to take the integration of q of xy plus t. Okay. Next, what's the next step is? The next step is that you have to equals both, because both are equal, both potentials are equal. So after comparing both, constant cancels with this constant, becomes equals to a new constant. I am taking k. So integration of p of xy plus q of xy equals to constant. This is our final relation what we have to find. Okay. So our next problem is 7.2.9. You have to prove that alpha x dy by dx plus alpha x p of xy equals to alpha x q of x is exact in the same of partial p by partial y equals to partial q by partial. Again, you have to prove, now you have to prove this equation alpha, okay, by the relation of exactness of equation, which you know, if equation is exact, so partial b by partial y become always equals to partial q by partial x. And your question also satisfied that alpha, and it's again a new thing is given, which is d alpha by dx equals to alpha x and p of x. So how to solve this relation? So you have to prove this equation is exact. So to prove this is exact, you have to start from here. So let's substitute, move this to this side, from right hand side to left hand side, so it becomes equals to 0. To show your equation is exact, first of all you have to move this d of x to other side. So d of x multiply by here, it cancel, here multiply, and here multiply, you will take common, so d of x. So the derivative along with any constant equals to q of x, and the thing which is along d of x, it is your p of x. Okay, so it is your p of x. So now your p of x value is this, and now your q of x value is this. To show your equation is exact, you have to take partial p by partial y, means partial equals to partial q by partial x. You have to take the derivative of q with respect to x, and you have to take derivative of p with respect to y. So if both answers are equal, you can say yes, this equation is exact. So let's start first. P of x, you have to take the derivative of p of x with respect to y. So after taking derivative, y, this alpha, and this p of x, this is constant, move back side, and y derivative is 1 multiply by this, only you will get this. And here there is no y, so the derivative of with respect to y is 0. Equals to derivative, you have to take the derivative of q, which is alpha, with respect to x. So here you will take the derivative partial by partial x alpha, means partial alpha by partial x, partial alpha by partial x. This is 0, so your partial alpha by partial x become equal to alpha p of x. Understood? Okay. As given, so d alpha by dx is given, d alpha by dx, which is equals to alpha x px. Put the value alpha x px. So see, alpha x px becomes equals to alpha x px. So you can say this condition satisfies, so our OD is exact. Understood? Remaining problems we will do next. So do practice these problems. This is your differential equation, homogeneous, non-homogeneous, linear differential equation, and exact problems. So for today, that's all. Thank you for watching.